Lesson 232, adding, subtracting, multiplying, and dividing fractions. This guy here, you guys are probably pretty familiar with him. That's Yao Ming. Yao Ming's funny face, right? He's laughing at our joke here. I was good at math before I decided to mix the alphabet in it. Objectives. By the end of this lesson, I will be able to answer the following questions. How do I add, subtract, multiply, and divide functions? 2. How do I read function notation? 3. And this isn't saying that this guy here, which I hope you guys are familiar with him, that's Michael Jackson. Michael Jackson is not bad himself. He just has a song named Bad. Or at least he repeats bad quite a bit. So why do fractions containing polynomials sometimes have bad values? And 4. How are the bad values reflected in the domain? So let's look at our vocabulary. This is just the notations that we're going to have, and it's pretty simple. I honestly have no idea why it's written like this, but if you see this f plus g, all it's telling you is you're going to take f of x and add it to g of x. Likewise here, when you see f minus g, you're going to take f of x, subtract g of x. This one here, they're being multiplied, so f of x times g of x. And then finally, it's kind of self-explanatory from here on out. Dividing, f divided by g, f of x divided by g of x. Now, undefined values is a value that is not in the domain of the function. And we're going to look at that here. Undefined value. So it's going to come up in a prereqs. So anytime you have 0 divided by a number other than 0, right? Imagine if you have 0 of something and you divide it amongst the classroom. People are going to get 0 of it, so it's always going to end up being 0. Now, if you have any number divided by 0, you can't divide anything between 0 people. So that's always going to be undefined. If you have time, you can go ahead and ask Siri what 0 divided by 0 is, and you can see what she has to say as well. So let's look at example number 1. So performing function operations from function notation, let f of x equal x squared minus 3x plus 4, and this is going to be g of x, forgot to change that, equal x squared plus 6x minus 3. So we're going to build a new function h of x. So we're going to name this h of x. Is going to equal f plus g of x. So it's going to equal f of x plus g of x. Yep, so we just start plugging in. So we know what f of x equals. F of x is right here. So this is going to be x squared minus 3x plus 4 plus g of x, which is x squared plus 6x minus 3. And this stays the same, h of x. That's what we're going to name our new function. So we can go ahead and rewrite this. We don't need the parentheses there. It's up to you whether you want to just scratch it or you want to rewrite it. X squared minus 3x plus 4 plus x squared plus 6x minus 3. Right, because we're adding two parentheses together, and we've done this before as well, you don't need these parentheses here. So now we can go to combining our like terms. See, we have x squared's like terms, we have x's like terms, and we have numbers that are like terms. So let's start compiling these. So h of x is equal to our x squareds. We have 2x squareds. Negative 3x plus 6x, that's a positive 3x. And then 4 minus 3 is a 1. And there's our final answer there. Now let's do example 2. So keeping the same f of x and g of x from above, build a new function w of x for which f minus g of x. So we're going to build a wx, and wx is going to equal f of x minus g of x. We'll do the same thing. We'll go ahead and plug in. F of x is x squared minus 3x plus 4. So this time things are going to change a little because we're subtracting these. So subtracting x squared plus 6x minus 3. And we can bring this down just to keep it consistent. So to start simplifying this, we do have to subtract this negative, this minus sign here first. And we can drop the parentheses for this here, for this first set of, for f of x. So we get x squared minus 3x plus 4 minus x squared minus 6x. Negative times negative 3 is positive 3. Okay. Now combine like terms. You have x squared minus x squared. That's actually going to cancel out. So we have no x squared term. Next we have negative 3x minus 6x. So negative 3 minus 6. That's going to give us negative 9x. And then finally 4 plus 3 is 7. There's our fully simplified answer there. Example 3. So we're going to build a new function. Let's see. We're going to build a new function. What's our function here? H of x, and we're going to be multiplying, right? Telling us to take f and multiply it by g. So h of x is going to equal f of x, which is 3x plus 4. And we're going to multiply this to g of x, which is 5x minus 2. So this requires us to do the FOIL method. 3x times 5x, that's 15x squared. 3x times negative 2, that's negative 6x. 4 times 5x, that is 20x. And 4 times negative 2 is negative 8. Okay. We want to see if we have any like terms. So we don't have any for the 15x squared, but we do have these two here. Negative 6x plus 20x, that gives us 14x, and then minus 8. And that's our fully simplified answer here for f of x times g of x. All right, last example here. We're going to be dividing f divided by g. So let's go ahead and write this out. So f of x goes on top, right? Because it tells us here. F goes on top, so this is 3x squared plus 13x minus 10 divided by g goes on the bottom, x plus 5. In these situations where we're not given, I'll move this over here, we can go ahead and write this out like this because we're not told to rewrite it as something new. So f of x divided by g of x equals that there. Now we don't have the skills yet. That comes further down in math for you guys to start simplifying this. In the meantime, the only thing that we're going to focus on is stating the restrictions for these functions when we are dividing them. So remember that the denominator is undefined when this is equal to 0. So we can never have the denominator equal to 0, so we have to restrict the denominator from being a certain number. So x cannot equal a certain number, and we want that number to be the number that would make this 0. If you have trouble figuring out what that is, take the denominator, x plus 5, set it equal to 0. Subtract 5, subtract 5. We get that x equals -5. So x cannot equal -5. Otherwise, this whole fraction here will be undefined, and we want to avoid that. So that whole thing right there will be our answer for example number 4.